Have you ever looked up at the sun on a clear day, feeling its warmth on your skin? It's a simple act, something we often take for granted. But have you ever truly considered the sheer immensity of what you're looking at? The sun is more than just a bright light in the sky. It's a powerhouse, a cosmic furnace that fuels our entire planet. That brilliant, life-giving star in our sky. It feels immense, doesn't it? A source of endless power, radiating energy across vast distances to reach our small planet. The sun's surface is a roiling ocean of plasma, constantly erupting with solar flares and coronal mass ejections. These events, though beautiful, are a testament to the incredible forces at play within our star. It's a dynamic and ever-changing environment, a far cry from the static image we often have in our minds. But it is difficult for our minds to truly grasp its scale. The numbers are so large they become abstract. Let us try to put it into perspective, to make the incomprehensible a little more tangible. We need to find a way to visualize the difference, to truly understand the gulf between our world and the star that sustains it. Imagine our Earth, this beautiful blue marble we call home. It is vast to us, a world of sprawling continents, deep oceans teeming with life, and towering mountain ranges. We travel across it, explore its hidden corners, and still, it feels endless. We build cities that stretch for miles, and yet even these massive constructions are dwarfed by the planet itself. Now, take that world, that seemingly infinite expanse, and imagine trying to fit it inside the sun. You would not just fit one, you could fit 1,300,000 Earths inside our star. Think about that for a moment. Over 1 million Earths, all nestled within the sun's fiery embrace. It's a number so large, it's almost impossible to comprehend. It highlights the truly staggering difference in size between our planet and the star that dominates our solar system. It's a humbling reminder of our place in the cosmos. But what if we turned this reality on its head? What if we dared to ask a truly absurd question? What if Earth was the giant and the sun was the smaller body? Imagine a world so colossal it dwarfed the star that currently gives us life. The first and most immediate consequence of this cosmic switch would be gravity. Gravity is the universe's master sculptor. Every step would be a monumental effort. Structures would collapse under their own immense weight. The mountains we know would be flattened into oblivion. The entire solar system, our familiar cosmic neighborhood, would be thrown into utter pandemonium. The delicate gravitational balance that holds everything in place would be broken. It might be flung into a new erratic path, or worse, set on a collision course with another planet. The solar system would transform from a place of celestial elegance into a demolition derby. Its immense gravity would act as a cosmic vacuum cleaner, pulling in everything that strayed too close. Our home would become a monster, devouring its own family. Imagine, for a moment, an object the size of Earth. Now, picture that object gaining mass, far beyond what we can comprehend. If it were to somehow become more massive than our sun, the consequences would be staggering. We would not just be bending or tweaking the rules of our solar system, we would be fundamentally breaking the very laws of physics that govern our universe. The delicate balance of gravity, mass, and energy would be thrown into complete disarray. This isn't just about astronomical anomalies. It's about the very fabric of reality unraveling. We're talking about a scenario that challenges our deepest understanding of how the cosmos operates. A scenario that pushes the boundaries of what's considered possible. It's a thought experiment that forces us to confront the limitations and the beautiful constraints that physics imposes on the universe. Consider an object possessing the sun's mass. Its destiny is almost certainly sealed. It is destined to become a star, a radiant beacon in the vast expanse of space. The journey to stellar ignition is a dramatic one, fueled by the relentless force of gravity. The immense pressure created by its own gravity, crushing inward with unimaginable force, is what ultimately ignites the nuclear furnace at its core. Hydrogen atoms are forced together, fusing into helium and releasing tremendous amounts of energy in the process. This energy counteracts the inward pull of gravity, creating a stable equilibrium that allows the star to shine for billions of years. It's a delicate dance between opposing forces, a testament to the power and elegance of the universe's fundamental laws. The star becomes a self-sustaining engine, powered by the very force that initially threatened to collapse it. So, let's return to our initial thought experiment, an Earth-sized object with the mass of the Sun. In our universe, governed by the immutable laws of physics as we understand them, such a celestial body is, quite simply, an impossibility. It is a fun idea, a wonderful flight of fancy that sparks the imagination and encourages us to question the boundaries of reality. But ultimately, it cannot happen. The universe has its rules, its limits, and its constraints. While we can explore these concepts in our minds, the physical reality dictates a different outcome. The sheer density required to pack that much mass into such a small volume would lead to catastrophic consequences, likely resulting in the formation of a black hole or some other exotic and equally improbable phenomenon. The universe, in its infinite wisdom, simply wouldn't allow it. Imagine a world vastly different from our own. A colossal Earth, twice the size, orbiting a distant star. Its surface is a chaotic canvas of icy volcanoes spewing forth plumes of ash and steam into a perpetually twilight sky. The atmosphere, thick and toxic, would be a swirling cocktail of noxious gases, utterly inhospitable to life as we know it. Could life, as we know it, exist on this impossible, giant Earth? The answer is a resounding and definitive no. The sheer mass of this hypothetical planet would exert a gravitational force so immense that it would crush any terrestrial organism. Its distance from its star, combined with its dense atmosphere, would plunge the planet into a deep, unending cold, a frigid wasteland where even the most extremophile bacteria would struggle to survive. The very building blocks of life, the delicate dance of molecules, would be disrupted by the overwhelming forces at play. This imaginary scenario, though fantastical, serves a crucial purpose. It shows us what happens when you tamper with that delicate balance, that razor's edge of conditions that allows life to flourish. Our existence is a fragile and precious thing, a cosmic gift dependent on a cosmic balance we had no hand in creating. Consider the precise distance between the Earth and the Sun. Too close, and our oceans would boil away. Too far, and they would freeze solid. The tilt of our planet's axis, the composition of our atmosphere, the presence of a protective magnetic field. All these factors and countless others conspire to create a haven for life. It's a symphony of interconnected elements, a delicate dance of physics and chemistry that has unfolded over billions of years. But how can we truly grasp the intricacies of this cosmic balance? How can we explore the infinite possibilities of what could have been? With modern supercomputers, scientists can create digital universes in a box, miniature simulations of reality where the laws of physics can be tweaked and tested. These simulations would be more than just a cosmic computer game. They would allow us to test the very foundations of our understanding, to probe the limits of what is possible, and to explore the consequences of even the smallest changes to the fundamental constants of nature. By creating these virtual worlds, we can begin to unravel the mysteries of our own, to understand why the universe is the way it is, and to appreciate the extraordinary circumstances that have led to our existence. We can explore alternate timelines, witness the birth and death of stars in fast forward, and observe the evolution of entire galaxies over billions of years, all within the confines of a computer simulation. By imagining how things could be different, by exploring the vast landscape of possibilities, we gain a profound appreciation for why they are the way they are. We begin to see the universe not as a cold, indifferent void, but as a place of exquisite beauty and profound mystery. The universe does not have to be the way it is. The laws of physics could have been different, the constants of nature could have been slightly altered, and the result would have been a universe utterly devoid of life. But it is. And that simple fact is, perhaps, the most wonderful and awe-inspiring mystery of all. It is a testament to the power of chance, the delicate balance of forces, and the extraordinary potential for complexity and beauty that exists within the fabric of reality. It is a reason to marvel at the sheer improbability of our existence and to cherish the precious gift of life that we have been given.